Today we're going to talk about measures of center and measures of spread. And these are two pieces of information that you're going to collect about just about every set of data you would ever work with. So first we're going to talk about measures of center, and most of these you have some experience with from previous math courses. So the first one is mean. Your mean is your average, and so you calculate your mean by taking all of your pieces of data, adding up the numbers, and dividing by how many pieces of data there are. So if you had a list of 10 numbers, you would add those 10 numbers up and divide it by 10. The median is the middle number, and the nice thing about the median, if you'll remember the last video, last week's video, we were talking about the outliers, and sometimes they can have an effect on your calculations. An outlier would have an effect on the mean, but it does not have an effect on the median, because in the median you line up all of your numbers and then in order, and then you find the middle number. So the middle number isn't affected by what that top or bottom number might be. So even if they're an outlier, all it really counts is the very top or the very bottom number, where the mean, if you're adding up that information, the mean could get skewed towards that outlier. So the only tricky thing with the median is if you have an even count of data, then the middle would be two numbers. So if you've got that situation, then in order to find the median, you would average those two middle numbers. So you would add those two middle numbers together and divide by 2. You'll notice here that we're skipping mode, and I just want to make a little bit of a comment on mode. When you're really talking about in-depth statistics, the mode is really not a piece of data that's all that important. You might mention it as an aside that there were a lot of one particular type of data. You had 10 instances of the number 5 in your data. But it's not something that really goes into the calculations. So the next piece of data that's important is quartiles. And quartiles are going to divide your data into quarters. So quartiles will take your data and give you your lowest 25%, your second lowest 25%, your second highest 25%, and your highest 25% of the data. So it basically divides the data into quarter-sized chunks. So 25% of the data is between each quartile. So the quartile refers to those numbers that divide your data into chunks. So you're going to line your data up in order, just like you do for the median. You're going to find the median, which sometimes is referred to as Q2 or quartile 2. Then you're going to pretend like your bottom half is a new set of data and your top half is a new set of data, and you're going to find a median for the top half and the median for the bottom half. The bottom half's median is your Q1, your quartile 1. The top half's median is your Q3 or quartile 3. Interquartile range is one of your measures of spread, of how spread out the data is. And the interquartile range is once you find your quartiles, you're going to take your Q3 and you're going to subtract your Q1. The nice thing about an interquartile range is it's one representation of a measure of spread that ignores the outliers, because it's going to cut off those end pieces, the outliers, and tell you the spread of the middle 50% of your data. Your 5-number summary is used to make a box plot. Your 5-number summary includes your minimum and maximum, your Q1, your quartile 1, your Q3, your quartile 3, and your median. So your 5-number summary is really what you need in order to divide your data into those 4 quarter-size chunks. The nice thing about the 5-number summary is it allows you to make a box plot. So in order to make a box plot, your box is your middle 50% of your data. So that's your Q1 forms the lower end of your box, your Q3 forms the top end of your box. Your median is a line somewhere in that box. Then your minimum forms the bottom tail, and your maximum forms the top tail. This is a box plot that includes the outliers. So when I say this is a box plot that includes the outliers, sometimes you'll have a box plot where your outliers are just points as opposed to the part of the actual whisker. So going back here, in this box plot, your minimum and maximum are included as part of the whisker. So this is one type of box plot. A modified box plot, however, is going to, if this minimum or the maximum were outliers, they wouldn't be included as the whisker. They would be points off to the side. So in order to figure out what an outlier is statistically, you take your Q1, and so the first thing you want to do is you want to find your interquartile. In order to statistically calculate outliers, the first thing that you're going to do is you want to find your 5-number summary, and then you want to calculate your interquartile range. Again, calculate your interquartile range by subtracting Q3 minus Q1. And then you can use that information to find outliers. To find any lower outliers, you would take your interquartile range and you're going to multiply it by 1.5. Then that number you're going to subtract from your Q1. That gives you kind of the bottom end of the whisker. If you have any numbers that are below that result, those would be lower outliers. So those then you would use a point, and I will show you what that picture would look like in a minute. Then you again take your interquartile range, multiply it by 1.5, and then you're going to add that to Q3 to find any upper outliers. So if you have any numbers that are above 1.5 times the IQR added to Q3, that would be an outlier. So then you have a modified box plot here. So what this looks like is your whiskers now, your whiskers go up to that number that you calculated that found your outliers. So when you went through and you did 1.5 times the IQR and subtracted that from Q1, that's the end of your lower whisker here. And the end of your upper whisker is that 1.5 times your IQR plus your Q3 gives you the upper end of your whisker. And then these two pieces of data at the bottom and this piece of data at the top are outliers. So you look at that number that is your kind of outlier line in the sand. And if you have numbers that are above that line in the sand, you would represent those using a dot, using a point. If you have numbers that are below your lower line in the sand, you would represent those using a point. The measure of spread that really is going to carry us through the rest of this entire course is standard deviation. And you'll see this nice formula for standard deviation. And the nice thing is you're really not going to have to ever use this. You will be able to use your calculator to find standard deviation. But standard deviation is basically where you take every piece of data you have, subtract the mean from that piece of data and square it. And you're going to keep adding those together. So each piece of data that you have, subtract the mean, square it, and then add it to the next piece of data that you subtracted the mean and squared it. So your steps are going to be, first you're going to subtract each piece of data from the mean, then you're going to square it, and you're going to continue to do that for every piece of data, and then this is the summation notation. It means that you're going to add all of those answers together. Then once you've added all of those answers together, you'll divide that by your number of pieces of data minus 1, and then you're going to take the square root of that answer. So one thing that you'll see a decent amount of times in statistics is you're not going to see a list of data that's just this long string of lists where you have 5 sixes and you list out all 5 of those 6s. you're going to see the data represented in a frequency table. So for example, in this set of data, we had 2 6s. So our data would look like 6 6 7 7 7 8 8 8 8 8 8 8 9 9 9 9 9 9 9 10. So instead of writing out that long list of data, we represented a frequency table showing that we had 2 6s, 3 7s, 7 8s, 7 9s, and 1 10.